Hi everybody, thanks for tuning into another math video. In this one I'm going to talk about a vertex form of a quadratic function, and we'll get there by completing the square. So to be specific, we are going to change standard form, that's y equals ax squared plus bx plus c, into vertex form, or y equals a times x minus h squared plus k. As you know, that is called vertex form. Okay, let's get started with our first example. This one will be a rather easy one by comparison, I suppose, where a equals 1. And I'm just saying that up front because that's an important thing to observe whenever you start one of these problems. What does a equal? If a equals 1, then you'll proceed as this example shows you. If a does not equal 1, well, you want to check out the next example that I'm going to show you where a does not equal 1, because it's a little bit different. Okay, so in this one, I just made up the quadratic function x squared minus 2x plus 7. All right, there it is in standard form. And the first thing I'm going to do is basically rewrite the whole thing, but I'm going to insert a little space there after my x term. Okay, so I've got x squared minus 2x plus something plus 7. And that plus something that I'm going to write in there, that's where the completing the square little magic number comes in. And as you may recall from our discussions in class, that number is found by taking b over 2 and squaring it. So b is negative 2. Negative 2 divided by 2 is negative 1. So if I take negative 1 and square it, I get plus 1. Now, I just added 1 into that equation. I can't just go around willy-nilly adding numbers into equations just because I feel like doing it. No. In fact, I can't add anything to one side of an equation. Oh, wait. Yes, I can. I can add 0. So if I add 0 to that equation, it doesn't change. It's fine. I can add 0 all day long to anything, and it doesn't change anything. But in this case, I'm going to add 0, but I'm going to add 0 as 1 minus 1. 1 minus 1 equals 0. So when I add a plus 1 and a minus 1 onto the same side of that equation, I've just added 0. But I've done it in a special way that allows me to complete the square. So b over 2 squared, I add that, and then I add the opposite of that to make sure that I'm really just adding 0 and not changing anything in that equation. Okay? All right, so when I do that, now I'll start to complete the square here, and that part of the equation right there, x squared minus 2x plus 1, that will factor down to my perfect square binomial there. That's what's nice about adding 1. So I have x minus 1 squared, and we've tried this a few times in class, so I hope that's okay. I can just write x minus 1. But now I've got 7 minus 1. That just equals 6, and I am done. Voila, it's in vertex form. In fact, I can now tell you right away that the vertex is 1, 6, and if I was to graph that on my xy axis over there, I'd nail down the vertex at 1, 6, and then I would just proceed to sketch my parabola from there. Okay? Now, so that one wasn't too bad where a equals 1. Now we're going to do one where a equals 3. Okay. So this quadratic looks like this, 3x squared plus 12x minus 11. That looks a lot harder. In effect, though, I've actually made it a little bit easy on myself because, well, you'll see in just a second. So what I'm going to do first is, just like before, rewrite it and add a little space in there after my x term. So 3x squared plus 12x plus something minus 11. Now that's something that I have to find. I'm going to do it basically the same way. At some point I am going to take that b over 2 and squared, but I'm not ready to do that yet. All right? So the first thing, since a does not equal 1, I have to divide those first two terms by a. All right? So when I do that, I factor out the a from the 3x squared and the 12x, and I get 3 parentheses x squared plus 4x plus something minus 11. Okay, so I've got that whole thing there in parentheses, and what I do now is I add b over 2 squared, which, if you can do that pretty quickly in your head, that gives you 4. So now, just like we added a number to the last one, and we had to add the opposite of that number to, in effect, add 0, that's the same thing that will happen here, but please observe. I wrote a 4 in there, and you'd think, oh, he just added 4. So I should add negative 4. But no, that is not what I did, folks. I really remember that 3 outside the parentheses there is multiplying everything inside the parentheses. So really, I added 12. I added 12. I wrote a 4, but that 4 is being multiplied by a, which is 3. That gives me 12. So I really have to add negative 12 now. Now I've compensated for that, and now everything is groovy. So I can proceed. So I'm going to say 3, and then there I've got my perfect square binomial there, and that will, I'm just going to look there at the x squared minus 4x plus 4. That means I've got x plus 2 squared, and then negative 11, negative 23 gives me negative 23. Voila, once again, and there's my vertex, negative 2, negative 23. So that was a little bit trickier example. Hopefully it didn't blow you away too much. Give you a little bit of a leg up on some of the problems that you're going to have to do in your practice. And so there's one easy one not so easy one, and I hope this video was helpful to you. Thanks once again for tuning in. And now go do some math.